Oh, this is all good. Hey, how's everyone going? Yeah? Woo. Cool. So, geez, we got a few people. Thank you for coming to the talk. Thank you for coming to learn a bit about Kubernetes and how it works with Drupal 8. So just like two quickies about me. So I'm a Bundy boy, Bundaberg, Queensland. It's actually like 8 o'clock in Queensland right now, so still a little bit tired. I'm a little bit of a Golang gopher now. Used to be a lot of PHP, now a lot of Go. So, but yeah, that's enough about me really. Like let's just get into this thing. So I'm sure everyone was here to see Kubernetes, to learn about Kubernetes. So a quick overview about Kubernetes. So we have this, so when Docker came out, we had our laptops, we installed Docker, we ran this image, it was magic, it was all good, but then day 2, we were like, wait a second, we got to run this thing in production, and production means running 2 copies of the thing at least, you know, like we need some kind of high availability there, and that's where Kubernetes comes in. It's an API set that sits over the top of multiple instances, so it turns a whole bunch of nodes into a single computer. So some people call it, say, like the kernel of the data center. Cool. So, so for this talk, I kind of self-quoted myself. I made up a quote. I was talking about those APIs, right? And yeah, to me, like, it's not about running up a Kubernetes cluster. It's about using those APIs, right? So, and they're very, very comprehensive. So there's a lot of APIs that we can play with. And today, I kind of want to talk about 4 of them. But before we start, I want to talk about the actual structure of the API. So every Kubernetes API follows a structure very, very, well, just like this. So we've got an API version, so that could be like beta 1, beta 2, v1. There's even extensions /v1. But the whole idea here is the Kubernetes community are very serious about their APIs. So, and you can consume multiple different versions of the same API. So you could lock into beta 1 for a while and then slowly move over to v1. That's probably enough of that. Kind is the type of thing that you're going to deploy or you're going to declare. So we'll see a bit of that soon. We've got metadata here. So this is all about describing the object, right? So we're giving it a bit of data. We're saying it's got a name. It operates within the namespace, which is a concept of, say I've got team A and team B. We don't want those 2 teams to kind of, you know, mess with each other's stuff. So, so that's what we've got here. So we've got team DS 2017. We have the ability to add labels to our stuff. So we can find, we've got some discovery here. So labels are all about saying, hey, you know, give me version 1 of app 1. Or you could say, give me like all the things tagged with app equals app 1. So it's all about discovery, and we'll see a bit of that soon. Next, annotations. That's all about metadata. So we can describe our objects that we're sending up. So we can put some extra data then that might inform maybe where it came from. It might inform some extra additional settings. But yeah, this is all about describing it and not about discovery. And finally, the 2 remaining objects here, which kind of changed the way that I think about ops in general, is all about this spec and status. So we've got spec saying, this is what I want, and then we've got status from the system saying, okay, this is what you've got now, this is what we've done for you. So it's all about declaring a state in the spec, and then the system coming back and saying, this is the status, which is incredibly powerful and very nice for decoupling multiple backends and extending out. So that's the core of the API. So let's get a bit of an example going. So everyone's like, Nick, you've just talked about APIs, but I want to know more about containers. So let's get into it. So we've got a pod. So I've got my container running on my local laptop, and I want to send it up, and I want to declare that image. That's what a pod's all about. So it's all about declaring a set of containers within a boundary, in a self-deployable boundary, and they can all talk to each other on localhost here. So that's why you've got like the egg omelet thing here with with multiple different containers. They're all within that boundary. And as you can see, it's not much of a stretch to declare it as a pod. A pod is like the core fundamental like building block of Kubernetes. We've got this kind pod. We're saying app1, let's deploy app1. And let's add some labels for discovery so we can link it up to different things. We can discover it via load balancers, things like that. We'll get to that soon. But then we're just declaring our image. We're saying, let's deploy Drupal 8.4.0. Also, notice that that's an array, so you can declare more and more and more down the line, but this is just a very, very simple example. So we've gone and said like kubectl create pod, and we've deployed our pod up to our cluster, right? Well, that's awesome, but you need to be able to route traffic to it, right? Like I've got this container up here, but what do I do next? And this is where services come into play. So services are all about grouping those pods that are deployed into a single IP address. So a software load balancer in this case. And this object came about very early in the piece for Kubernetes. It was all about pods and services, and it was all about the microservices movement around that time. So then you could start to deploy all these different apps, and they could all talk to each other on these different IP addresses internally on the cluster. Now, we talked about labels before, and in this case we're saying, just like before, we're saying let's deploy a internal load balancer or a service called app1 as well. That's just for discovery, so we just called it app1 as well. It could be whatever we want. But here in the spec, we're saying, okay, let's target all the pods that have app equals app1. Notice that we don't have any version in there, so you could send up like another pod, you could deploy another pod, do like a blue-green style deployment. But it's all about that app equals app1, and it's incredibly flexible in this way for you to be able to query and then return a set. And then finally, we've got our balancer sort of rules here where we're like, okay, let's receive traffic on 80, port 80, and let's tunnel it through to 80 on the instance. So that's pretty standard load balancer stuff. So I think for a lot of people, they'll be like, sweet, that's an API for load balancers. Cool. So pod, grouping our pods or our containers via a service for discovery, but we're all web developers, right? We're not really microservices dudes, you know. It's all good, but we need to get some traffic into our cluster, right? Services are all about communicating within the cluster. So now we have ingress, so which is all about saying, okay, let's get some web traffic into the cluster and then let's route it to our container. And you'll see that that's very similar to a vhost file, like an Apache or Nginx style vhost file, where we're saying, give me an app1, here's my host name, so DrupalSouth, and then we're saying, like, let's listen on / on root, anything under root, let's go to the app1 service. So we've wired up our ingress to our service to our pod. I know I'm going a bit quick, so if there's any questions, just hit me up. But yeah, I'm trying to recap. So we've got this vhost thing that then talks to our internal load balancer, which then goes off and then routes to our pod. So in 3 APIs, we've deployed our app. But you know what? Like we live in a stateful world. We need storage. You know, we've got files for our app. You know, we've got MySQL up in there. Like. So this is where the concept of persistent volume claims come into Kubernetes. So we've got these APIs for saying like, give me a load balancer, give me a vhost, give me the routing in, you know, deploy my pod. But we also have some really cool stuff for saying like, give me some storage, man. So in this example, as a dev or as an op, I can say, give me some public storage, some public file storage, right? And then with the annotation, I'm saying, go off and just provision the standard storage. I can give it some rules. I can say, hey, you know, this volume that I want it to read write many, which means I've got multiple web heads, multiple pods mounting this thing, so multiple web heads writing to it. It's not like a standard disk that you've slotted into a host that can't go across multiple nodes. And I've also said, hey, I probably want at a minimum 20 gig. So, we've got quite a few files on this project. But the cool thing is with, 10 lines of YAML, the service then comes back with this line at the bottom and goes, sweet, here's a volume. That's it. I've got storage, right? Takes about 5 minutes, but yeah, it comes back with storage, and yeah, it gave me 8 exabytes, which is pretty awesome. Try and fill that up. It's a lot of public files. So going back to our pod, we can now say, okay, that volume that I just asked for, let's mount it. Let's declare it down the bottom here and say public files, and then let's go up into our container, and we can select which container we want and mount it into like app sites default files. Cool. So I just want to point out that back in that previous slide, a lot of that magic, if anyone's provisioned EFS on AWS, that you would have probably noticed that fs-xxxxx. So that's an AWS EFS volume, and that's powered by some of our open source project work. So if anyone's keen to look into storage classes and things like that, like these automated provisioners in Kubernetes, like we've contributed one to the community for EFS. Cool. So let's just recap. I got this container. I'm grouping it by a service. I'm routing some traffic in with my ingress, and then I'm mounting some storage in there. I've said, give me a disk, let's mount it, let's get some public files. But that's only a small piece of the puzzle, right? Like, there's a lot of other higher level, like declaring a pod is all good, but we want some higher level APIs. So that's why there's many more APIs that you can use. And in fact, all the big ones there are the ones that we leverage for our hosting. So it's like when I say it's a comprehensive set of APIs, like this thing fits the bill, right? Even down to like cron jobs. You've got an API to run cron now, and you can tie it into your alerting. You can see if that thing failed now. It's not just like a single line on a box somewhere, where you have to do some crazy log management to work out if it failed. That's like an API wrapping cron. So just as an example, I know config maps came up before. We use that. That's where we store secrets and things like that, decoupling it from the code. But anyway, let's focus on the 4 APIs. Cool. So, we've gone through these 4 APIs, and I'm kind of teaching you guys a new set of APIs, and you're like, Nick, we've got this Docker Compose thing. I've been using this Docker Compose thing for ages. It's awesome. I don't really care for your YAML. I've got my YAML, and that's fine. So, but you know what? Like, if you look at them side by side, you might start to see a pattern, drill it down. They're not, I know that there's a lot of stuff omitted here, but they're actually not that different. And that's when I was like, oh my God. Like a pod equals a Docker Compose.yaml file, right? So we built a tool to demonstrate these APIs and also to use internally to solve a problem. But first, why? Like I got Kim, I'm like, dude, I'm gonna build a tool, and he's like, another tool? Really? Why? Didn't we have a tool yesterday? Like, what's this one gonna do? So we gotta justify it. So to do that, we need to just do like a quick PreviousNext testing CI history. It won't go for too long, I promise. So 2012, we had a Jenkins box that was running a whole bunch of ops stuff, and reluctantly the op at the time let me install PHP on there and put some PHP CS on there. I know Miguel was horrified. But yeah, so we put PHP CS on there to start doing code sniffing on our pull requests, and then that became a LAMP environment. We're like, okay, sweet, like we're testing that code, but does it actually run a site? So then we started doing, all that vhost manipulation and, all that stuff with an API we were just doing with like some bash and like echoing in and resetting, and, cleanup was a mess. And then we went, well, that doesn't scale. That's a single Jenkins. So let's turn that into lamps. Let's use like a master node setup. But you know, Docker came out, and then it was like, well, we want to test between like PHP 5 and 6, 5.5 and 5.6. So Docker's around. Let's turn those lamps into Dockers. And then it's like, oh damn, yeah, we kind of built an orchestrator, right? we built a Kubernetes, and now we're managing it. And around this time, we had ECS come out. So we had AWS ECS. We were like, you beauty, like this is awesome. We don't have to worry about, you know, running this kind of stuff. There's an API there. It's managed by AWS. Awesome, cool. But we kind of backed the wrong horse. It's there weren't enough APIs there. It's a very simple service. It's generally got the concept of just that pod and a few more services, things for keeping it running, but there's not too much else. You have to bring a lot yourself. So we kind of took a recap. We went, okay, you know, a couple of years, what's the state of things? You know, like we've been talking about things like Circle CI and Travis, and those have really, like with Docker coming out, those guys also said, let's, you know, standardize on Docker, which made CIs boring, right? Like you just declare the containers that you're running, and now you can just, you know, run your code in there, and it's all the same as your local. So we had this common consistent format for our CI pipelines. And in that recap, we kind of went, okay, well, we built a CI pipeline. CI pipelines are way better now. But the value that we had were those temp environments, like way back, you know, when we said lamp time, like that's the value that we added. So we said, okay, well, yeah, let's build a tool, right? Let's move off ECS. We still are running like ECS. We're moving to this, but let's use Kubernetes. Kubernetes is clearly the winner in the container orchestrator space. So let's move to that, right? So I want to announce the project. So so we have a project called Mates, which incorporates those 4 APIs. So it's kind of a really nice little tool for you to get used to those. Like, it's simple to install, and it's also a really nice, easy tool that uses those 4 APIs. You can kind of convert your Docker Compose file into these Kubernetes objects with a bit of workflow around there, but yeah, it's all about being able to learn those APIs at the same time. So, but let's kind of go into depth a little bit. So we kind of gave it a bit of a lovely, I don't know, line. So toolkit for building ephemeral environments and via a pipeline. So, what does it do? So we just aimed for simplicity. That's the key. So take that Docker Compose file, spin it up on a Kubernetes instance, and just do a few extra things around there. But the key is, like, we're just building on top of Kubernetes and then doing things like those routing rules in there. So then you can get to your Mailhog and your Solr instance. So, you know, like you've got it on your local, and you can hit that like port 89. Or you can go /mailhog, or, you know, however you have it locally, you can see that local mailhog. But once you get to a pull request environment, you can also access it there and test it out and show people things. And instead of spamming everyone, you know, with email, you can just go to that mailhog interface and go, this is what the email looks like. So, yeah, cool. So, but this is conceptually what it looks like, and we want to be agnostic about pretty much every piece of this. So, you know, like you notice I say pipeline, that means anything from, yeah, like Travis to Circle to Bitbucket pipelines. And then just to the fact where it's running on Kubernetes. So anything from like AWS's COPS to just spinning up a GKE cluster on Google Cloud Platform, so, or Azure. So, you know, like the title had Kubernetes in there, but it also had Drupal. So I want to do a demo to show how this integrates with Drupal 8, how this works on a Drupal 8 project. So for that, let me just cut over. So So this is my GitHub repo. It's a very, very simple, just Drupal 8 site, vanilla Drupal 8 site. We can start from, we can start from the Circle CI, actually. Well, actually, we'll start with the Docker Compose. So these are all our open source containers too. This is our open source container suite. So we have a 7.1 running. We mount our code in, and so we've got a database. We give it some credentials, mail, search, so Sol and Mailhog. So that's pretty standard. You can copy and paste and get going with this. And then I just have a very, very simple workflow for the project. I just got an install. So where in my mates.yaml file that declares what actually runs when the environment spins up, I just run make install. Just install my site. And what that looks like in a Circle CI pipeline is this. So we're checking out the code. We still believe that you should run your tests or really quick tests within this pipeline. So you don't want to bootstrap an environment if you've got a syntax error. You don't want to bootstrap an environment if your unit tests are failing. You should fail fast with these things. So we have control over that. And then finally, we've got this mates command, and that's all that you need from the file to bootstrap it. So we pass in the Git revisions, see how we're not actually, baking in, like we're not being biased. We're saying, okay, well, let's use the environment variables from the pipeline to bootstrap this thing. Let's give it a name. Let's, give it some DNS, like whatever I want it to, respond to. And then you also have control over basic auth, so you can pass some basic auth to lock it down. And then finally, to actually make things look pretty within these pipelines, you can also run additional steps within that environment, so you get that broken down look, which is what you'll see here. So this is my topic branch that I pushed. I cleverly called it the branch topic branch, and you can see we're running our unit tests. We're echoing. We're bootstrapping the environment, right, which is running that make install. So you just quickly cut to the make file for a sec, just so you can see under the hood. Like that's a couple of commands: composer install, DrupalSouth install, set some permissions just to be sure. That's all that's running in this pipeline. So it's running a composer install, installing, that's it, and then running that extra step. So we can actually, if a step fails, it's not like this big long bit of text that you've got to scroll through to figure out where it failed. It's actually acknowledging the fact that pipelines do have this broken down view. Cool. How we wire it up from the other side is we set a few configs. So this is something that can be kind of organization-wide on Circle CI or Bitbucket or wherever you're deploying it. It's a very simple authentication method via a token between the API running on the Kubernetes cluster and the local mates CLI. But also notice that we've got this env foo thing going on here, mates env and then foo. So what that's going to do is that's actually going to inject foo equals bar into the remote environment. So this is a really nice way to just maybe add some like AWS keys or things like that into the remote environment. You can still use the baked in sort of key, secrets management inside your pipeline for this stuff, and it'll just end up on the remote environment for you, but be careful. And then finally what you end up with is this topic branch, so topic-branch mixu.com. And the extra stuff that we've added in place is you can see, okay, well, I got this site, but what if I want to, play around with Mailhog? So by default, we just bake in and say, okay, /Mailhog is a thing. So if you go to /Mailhog, it will just route through to that container for you. Same with Solar. So you can tweak around at those settings. So you could spin up an environment and then go, ooh, that's not right. Let's just quickly debug that. And this is the project page where you can get started. So that kind of lists everything. We've spent a lot of time, like I know Lee mentioned conference-driven development yesterday. That's definitely what got this to where it is. Oh yeah, and I don't know, there's a few laptops in here, so see that star button? Like, press the star button for me, please. Like, shameless plug. I may be refreshing my page every now and then to get that love, so. But yeah, we have some very, very clear documentation, and we plan to contribute way more documentation on how to get started and an actual tool to bootstrap that cluster. But in this case, the environment is running on GKE, so you don't even have to learn how to use Kubernetes, or sorry, how to deploy a Kubernetes cluster. You can use GKE and the instructions here. And then, yeah, you can pick the pipeline of your choice, so whatever works for you. Yeah, that's cool. So that's, you know, that's the demo. Didn't go out